I keep asking like we're using whenever I would use.
Hello, can you hear us? Oh, let me get the microphone.
Because I want to include it in our poll.
Where's my bag?
It's just cool.
I think you should all stand. Is it on? Can you hear us?
Turn the speakers on.
Oh, they're not on, that's why.
Are you hearing me now?
There we go. Perfect.
Are you hearing me now? Yes.
Yep, perfect. Yeah. What should we have? Oh, it's nice. So nothing. Good. Here we go. Good.
So you can hear us, right?
You can hear us? Perfect.
Yes.
He's actually gonna be leading the interview this time. It's when the first things will be starting. So yeah.
Right.
All right.
Great. Okay.
Great. All right.
So, my first question to you is, so for your profession, you are a computer data scientist, correct?
What's the question?
You are a computer data scientist, correct?
Leave off the word computer. I would say data scientist.
Data scientist. Okay. So, what exactly do you do as a data scientist?
Well, data is everywhere in the world, for one thing. So every time you're on social media or you buy something or you travel somewhere, someone's tracking you and what you're buying, what you're doing, and data are collected. And so businesses, agencies, and scientists are exploring these data for patterns, trends in the data, correlations, and those types of discoveries are informing how we shop, how we buy, how we learn about our world. So what I do as a data scientist is I help these different groups, whether they're government or commercial firms, to understand their data.
Okay. Thank you. So the second question would have to be, as before you got into your profession or when you were a kid in high school, what were your favorite subjects and such? Also, were any of them like specifically physics, or did you develop that interest later in life?
Well, I first got interested in astronomy when I was 9 years old, so it was well before high school. And sometime when I was probably in middle school, I learned that in order to become an astronomer, one needed physics and math. And so I pretty much enjoyed those subjects. I didn't really have physics till I was a senior in high school, but physical science, mathematics, all those things were very interesting to me and became sort of the ability, the enabler, so to speak, to let me do that career. And so it all started early in life, but once I got to high school, we had a computer in our school, and it was actually very early use of computers in schools back when I was that age. And so a good combination of computer skills, math skills, and science really helped make everything come together.
Okay, thank you. Building upon that, you said you had after you found out the requirements for being an astrophysicist, meaning like higher level math and such. I have a question that might build on that. It's like, how have your higher level math classes that you've taken throughout your schooling like helped you in your profession? Was it the concepts that helped you in understanding that, or was it the actual just math?
It's a combination of all those things. I think first and foremost, the thing you learn in physics is how to solve problems.
Mm-hmm.
Anyone who's ever had a physics class, you know it's all about solving problems.
All about, yeah.
And so math, of course, math is all about solving problems, but physics is interesting because it's applying math to solving real-world problems. So success in the career really comes about by knowing how to solve problems, and of course, having the mathematical skill and tools and understanding the concepts of math makes that possible.
So, as an astrophysicist, your job sort of goes under the realm of like STEM jobs. So, how do you think? What do you think about STEM jobs in the future, and how like that market will sort of expand or transform?
I think it's exploding right now. So
Yeah.
I think anyone who has any interest in engineering, math, science, guaranteed job employment is what I would say. I mean, it's just like everybody is trying to get these people with these skills. I mean, that's the real sort of transformation I see now with the what people call the digital revolution, or maybe we call it now the data revolution. Is that every business, no matter what the business is, whether it's selling groceries or pumping gas or rocket science. Every discipline is dealing with digital information, and they want people who know how to solve problems with digital information. So the STEM skills of science, engineering, and math, all those technical skills become part of what people will hire you for, basically.
This is also related to your job. With other people that we've interviewed, many of them have said that they found out what they want to do while living in the middle, or what they want to do for a living in the middle of college or even after college. How was your experience with finding your passion, or like finding what you really wanted to do?
Well, I guess I stumbled across it, like I said, when I was 9 years old. What happened then was I got a Christmas gift from an uncle, which was a beautiful astronomy book. And it was all filled with pretty pictures, so it wasn't, very technical, but it was just beautiful images of space and galaxies, planets, and everything. And I just said, I got to do this for a living. I mean, I was just hooked. The more I read about it, the more I realized that the discovery, the whole idea of discovery of new things is what a scientist does, and so it just sort of all came together for me. And I guess like I said, what really made it possible was when I read that the key skills are physics and mathematics, and those are the things I was really good at in school. So it just sort of made sense to continue that path. And so as I went through college, I just took all the courses that made that possible. So now I realize not everybody has that same path. Some people discover their passion afterwards, and that's fine. So it's always good to keep an open mind that there will be new roads that you'll discover that you never knew about. And so I started teaching at the university about 12 years ago, and we started a brand new program in data science. There was no other program in the world in data science. So there was probably no person going through high school or middle school or any school who ever dreamed they would become a data scientist, because it didn't exist. Mm-hmm. So we helped create the field, and we created the degree programs, and now it's basically, if you look at the job sites now, it was just a report this week that the number one best job in the United States right now is data scientist. I mean, it's the number one most sought after position. Mm-hmm. It's like extremely well paying, and the work is really interesting, and you can't think of a better thing to do if you ask me.
Definitely. So this is more back to not a super serious question, but more like what experiences in school have you remembered the most, and what sort of student in high school were you? Were you like hardworking? Were you like a student that like understood everything and then sort of like let that carry them through high school?
Well, that was sort of me, I guess.
Okay.
I love learning. That's another thing about STEM, is that the science and mathematics and engineering fields are always changing. So if you're going to be a success there, you have to be a lifelong learner, we call it. That you have to love learning new things, and I was that guy, I guess. Mm-hmm. I guess you could say I was a little bit of a nerd, but I wasn't entirely a nerd. I had my share of dates and things like that, so I wasn't entirely all alone like that. But no, it was a very good experience in high school for me. I really enjoyed my friends and doing things together, and there was a small group that formed an astronomy club, which we had some really interesting adventures looking at the stars and going out into the deep, dark parts of the state where there were very few lights and setting up telescopes. So it was an interesting set of memories there.
Okay. Well, would anyone else have questions on that? Because I run through mine.
What about how about perhaps maybe some challenging things that you dealt with? I guess both in data science and in astrophysics.
Well, I guess the one of the challenges of any scientist is finding interesting problems to work on. And the good news about data science for me is that every problem that we encounter has yet to be solved, and so you can just pick and choose, find the interesting ones and start working on it. In astrophysics, I sort of came across it just by taking a class where it was a very hard class. It was probably the hardest class I had in graduate school. We had a special name for this class. The catalog name for the class was Theoretical Astrophysics, or Readings in Theoretical Astrophysics, but we called the class Russian Roulette. And the reason I say that is because the professor who ran the class, he would give us like 3 or 4 articles to read every week. And then the following week, he would just pick a name out of the hat, and that person had to stand up and describe those papers to the best of the class. Okay, so it was truly like Russian roulette.
My dad did something similar during medical school. It was...
You probably had some of that experience before.
Yeah.
So we had some interesting things there where some students would get picked one week, and they would think, oh, I won't get picked next week until they didn't read the papers, but they were picked the following. So anyway, when I took that class, I mean, it was very, very difficult, really high-level stuff. Even all the physics and astronomy and math I had already had, it was very complex stuff. But in the readings that we did, I discovered a totally unsolved problem in astrophysics, which was completely outside the field of that I was pursuing at that time. And I said, oh my gosh, this is so interesting, I have to do this. And so I basically just completely went from the study of basically nearby stars to very distant galaxies, just sort of overnight, so to speak. And it was because of that challenge, the challenging problem. And so I always say to people, don't run away from challenging problems, because even if you fail, it's in failure that you learn about yourself and you'll learn about the thing you're studying, and that's okay.
Now, remind me again, where did you work at when you were an astrophysicist?
Okay, so I got my PhD at Caltech. So Caltech, at the time, probably still is today, one of the world's leading institutions in ground-based astronomy. Of course, there's a lot of telescopes in space now, but back when I was there, it was the number one institution. And so after that, my first full-time job was at the Hubble Space Telescope. So look, if you see over my shoulder, there's a little model of a telescope behind me back here. I'll grab it for you for a second. So I walked away, and I bring my little model of the telescope for you to see.
Mm-hmm.
That's so cool.
That's interesting.
So I worked with the Hubble Space Telescope as my first career, and I helped develop the entire database system for all the scientists in the world to access the telescope.
Oh, wow.
So you can't read the little plaque here, but it's a NASA award that I got for developing that system for the whole world of astronomers. And, so I did that for 10 years and worked on databases and data systems, while at the same time still doing my galaxy research. But I got really, really interested in what data could do for discovery. That is, the more data you have, the more you can learn about things. And it wasn't just galaxy things, it was everything in the world. So I would like to tell people, if you're on social media, if you're on any kind of, if you have a mobile device, which we probably all have, someone's collecting data on you and trying to understand what you buy, what you like, where you go, and sell products to you accordingly. So it's not just about selling stuff, it's always about discovery for me, whether it's scientific discovery or something else. So I did that for 10 years, and then I worked at NASA at a facility called the Goddard Space Flight Center, where we basically archived the 15,000 plus science data sets that NASA had collected from all their space science experiments since the beginning of NASA. And I got more interested in that, and then I left NASA 12 years ago to become professor of astrophysics at George Mason University. Funny thing was, I've only taught one astrophysics course in the last 30 years, even though I was professor of astrophysics, because my goal was to create the world's first data science degree program, which we did. I did that for 12 years, got a little bit of a reputation worldwide, and some very great company called Booz Allen Hamilton hired me 7 months ago, and that's where I am now.
So then, what's the difference between all those jobs? Is like maybe one maybe more stressful, less busy? Can you perhaps even describe, contrast the differences between them?
Yeah, good point. I think everyone who's had a university or faculty professorship position would say it's probably the most stressful thing out there, but also at the same time it's the least stressful. And what do I mean by that? Well, least stressful because if you get a faculty position like that at university, so if anyone is aspiring to do that in your group there, if you get tenure at university, it's guaranteed employment for life. So no matter what you do, unless you kill somebody, they can't get rid of you. And you can choose to work on any problem you want and choose to teach any class you want. So it's wonderful. But on the other hand, it's always hard work to write the grant proposals, to get the funding to support your students, and writing research papers, because that's how you get promoted. And anyway, so there's a lot of stress and a lot of rewards. And so I'm in a job now where I have, some of that still, but it's slightly different because the reward system in the company I work with is not promotion, but actually a better salary. So I'm not complaining.
Great.
I forgot. What was it?
Okay.
Really?
I'm just trying to think.
Oh, I'm drinking too. So. I'm drinking too. So.
So you didn't ask me about my name, so my friends call me Captain Kirk.
Oh.
And many years ago, I'll just tell you this story. When I was working at the Hubble Telescope project, my friends called me Captain Kirk, and I'm sure you've all heard of the Hubble Telescope, yes?
Yes, yeah, of course.
So being a very famous institution like that, they would get lots of phone calls from different organizations asking for speakers, scientists to come and talk about the Hubble Telescope to different groups all over the country and the media everywhere. And so one day they get a phone call from someone that says they're running a Star Trek convention in Baltimore, and they needed a speaker to talk about Hubble science to the Star Trek convention. They asked our press officer, did he know anybody who could do that? And he said, well, I don't really know for sure, but we have this guy here that people call Captain Kirk, so maybe he'd do it. So 25 years ago, I accepted that invitation, and I've been going to that same convention every single year for the past 25 years, and I've met some of the stars of the movies and the TV shows, plus a lot of other shows, the Star Wars and Star Trek and Babylon 5. And, if you know any of those science fiction shows, many of those shows, their stars would appear at these conventions and talk about the cool stuff they do in the movies, and the technology people, like the people who do all the CGI graphics and the special effects in the movies, they would come. And and I would stand up and talk about science, and people would still be interested because people sometimes say truth is stranger than fiction. And some of the stuff that happens in the universe is sometimes even stranger than you see in the movies. So it's always been fun to have that conversation with people. And the very first person I ever met was a guy by the name of George Takei, who played Sulu, Lieutenant Sulu in the series. So he's the first guy I met 25 years ago at one of these conventions, and then I have his autograph in my program book still. And he says, he signed the book to me, he said, to Captain Kirk, live long and prosper. So I figured I've got to keep that one.
So I was wondering, what are the main differences between working as a data scientist and working with data in astrophysics?
Well, it's not a whole lot different, because the transformation from one to the other was pretty easy for me, and I still call myself an astrophysicist. So just for example, people say, well, how does it feel to change your career? And I said, I have never changed my career. I've changed jobs, but I've always been a scientist. And so the transformation is a smooth one, because scientists are always using data, running experiments to answer questions, to solve problems, and to make discoveries. And so data science is different in that the data sets are not astrophysics data, but they could be anything. And so I actually find that quite exciting, because one day, today I'm talking with people in the Social Security Administration about health analytics, and on the day after tomorrow we're having a data hackathon where we're helping the local pet shelters collect and analyze their data to understand pet health and pet adoption in the region. And then a couple of days after that, I'm going to be talking with someone about oil and gas industry and how we can use data for oil exploration. And then we're having a hackathon with the U.S. Track and Field Federation to improve statistics, visualization, and stories that you can tell with statistics of track and field athletes leading up to the Olympics next year.
Interesting, yeah.
For 2 years. Mm-hmm. And so it's all over the place, and it's fun.
I have a question.
Yes.
So you said you helped develop the database for scientists to use on the Hubble telescope, correct?
Yes.
Okay. Can you explain how big the scale of resources were put into helping make it? Because it's a pretty big thing, making these very powerful telescopes. So how much time and effort and maybe resources were put into making the telescope? just from your perspective?
Yeah, that's a good question. And it's got an interesting answer. I've looked at another very large telescope, which you're going to hear about in a few years, and I'll tell you about that. But with the Hubble, the telescope itself, all the engineering and the 25 years of operation and design, launching it, everything, that's like $6 billion. Okay, so that's your tax dollars at work, $6 billion. And the data archive, the original Hubble Science Telescope data archive, which I worked on, of course I left Hubble 20 years ago, so things have evolved since then, but that first archive cost 30-something million, let's say $30 million. Okay, so 30 million is 1/20th of 6 billion. Okay, so it's 5% of the total budget of the project was put into the data archive.
Was that an international thing, or was it just?
Say again?
Was that an international collaboration?
Yes. The two main contributors to the project were NASA, the American, the National Aeronautics Space Administration, and ESA, the European Space Agency. So ESA put in about 1/6, I would say, and NASA the other 5/6. So anyway, so that archive cost 5% of the total budget. So now we're building this much huger telescope. It's not going to be in space. It's too large to put in orbit. It's called the Large Synoptic Survey Telescope. It's being built right now, LSST. You can look it up. The LSST is going to be based on a mountaintop in Chile, and the data archive is fully 1/3 of the price of the telescope.
Ooh.
Oh, wow.
And it's going to be an enormous telescope. It's going to produce, essentially, we figured this out, it's going to be a 10-year study of the night sky, so it's going to do repeat observations, like what we call cosmic cinematography. It's a movie of the night sky, repeat every night for 10 years. And we figured in the first 30 minutes of this 10-year movie, the first 30 minutes, it'll collect as much data as the Hubble has collected in the last 25 years combined.
Interesting.
Wow.
It's going to be a huge telescope, an enormous amount of data, and it's just an open exploration and discovery for everyone. So one of the goals of this project is to make the data available to every science classroom, every person in the U.S. and in the world who's part of the project, and so every one of you can access it and do discovery.
So can you expand on that? Are they going to make a phone app that you can lend help to, or you just you follow them on what it
Well,
does?
I think all those kinds of things are going to be possible. We've talked about phone apps. We've talked about sort of mobile access to the data, maps of the sky where you can. So, for example, if you've used Google Maps, right? So you go to Google Maps, right? You can find locations of things, and you can look at the satellite photo and see a photograph of your school or your home or whatever. And we're going to do the same kind of thing with this, where Google is actually going to serve our data to the general public. There's going to be a big data archive that I mentioned that the scientists will use, but that's got a lot more complications that scientists will understand. But the Google is going to help us serve the LSST data to the world, and it'll be like Google Sky, where you can just pan around and zoom and find the data, find interesting things like supernovae or colliding galaxies or new planets or exploding stars of all kinds. And just a lot of different things are going to be observable there, and you will be able to just explore it on your desktop or on your handheld device or whatever.
I guess we are out of time. First of all, a few things. Okay. Yeah, that's our balance. Yeah, used to it. I guess I have a few questions for you. Number one, can we take a picture of you really quickly?
Yeah, sure.
Sure. Number two, I actually have the audio recording of this. Is it okay if I release it online to the general public?
That's fine, yes.
And I think that's about... Oh, do you want the photo also? I can post it on Twitter.
That's excellent. I look forward to it.
All right.
Alright, thank you.
Okay, everyone, get in the photo if you want to come. If you want the photo.
Yeah, that's fine. This
Take the picture. Thank you. Thank you, Kevin. All right.
No.
That's a picture of a picture, huh?
Ready? 1, 2, 3. one more. 1, 2, and 3. Alright, I think that's it.
Yeah, that's it. All right. Thank you. Thank you. Hey, give a round of applause, guys, and thank you, Wilson. Thank you so much.
Well, thank you. Thanks again.
All right, we'll see you.
All right, bye. Thank you.
Bye.
That's good.
That's good. That's pretty good.
Yeah.
Really good. I didn't know he did that. That was.
Man, you completely killed all my questions.
Oh, yeah.